let's look at how to use these simulations effectively. First of all, the question is going to come up, and then at the top you'll see a description of the type of question. Now if you have a problem with this particular type of question, note it. Note, I have trouble with algebraic abstractions, for instance. That way you can keep a list of what you need to work on. Now you'll notice the numbers at the bottom of the screen. Now these are your levels of difficulty. If it shows 400, 500, 600, 700, 800, that means you need to get this type of question right to get at least that score. You'll see that that changes as the questions get more difficult. For instance, if you see a 700, 800, that's like a 700, 800 level word or question. And utilize the control bar at the bottom. This allows you to go to the next one if this is a real easy question for you. It allows you to go back and review them, or you can pause it and try to work the problem yourself. And now let's move on to the questions themselves. Now we've got 25 here. The most you'll encounter on the new SAT is 20 questions, but in order for us to get all the types of questions in, we use 25 here. This first problem is really a conversion problem. How many 16 fluid ounce cups are needed to hold 4 quarts of water, given that 1 quart's 32 fluid ounces? You want to convert the quarts to ounces. Now if there's 32 ounces in a quart, 4 quarts would be 4 times 32, or 128 ounces. And if we've got 16 ounces per cup, and we want to know how many cups are needed, we simply divide 16 into 128. And 16 goes into 128 8 times, which tells us we need 8 cups. Now this is a work problem in a way, but really it's just more of a ratio problem. We want to know how many pies Ida can make in 6 hours if she makes 3 pies in 9 hours. Well, you simply set up your ratio. 6 hours are to 9 hours, as x pies would be to 3 pies. Then you cross multiply, so you've got 6 times 3 equals 9x. 9x equals 18, so x equals 2. This problem is an algebraic equation, but really it's a question of manipulating fractions and dealing with fractions. In this case, we've got w plus 3/12 equals 1/4. Then w equals what? Well, the first thing we've got to do is subtract 3/12 from both sides. So we're left with 1/4 minus 3/12. But if we simplify 3/12, we see that it equals 1/4. And 1/4 minus 1/4 would be 0. So w is 0. This is a word problem that involves percentages. Now, in order to pass this test, a student has to answer 70% of the questions correct. If it's a 40-question test, how many questions must they answer correctly? Well, we're dealing with 70% of a 40-question test. 70% is represented in decimals as 0.70. Then we simply multiply and do 0.70 times 40 to find out they have to get 28 questions correct on this test to pass it. Now this is a geometry problem involving identities of angles. They're not going to tell you straight away that these lines are parallel. Rather, they're going to say line P is perpendicular to lines M and N. Well, if a line is perpendicular to 2 lines, that means those 2 lines are parallel. This tells us M and N are parallel. Now note that anytime you see figure not drawn to scale, you can't trust the drawing. You can't just trust the figure. In this case, you can't assume M and N are parallel because they look like it. But knowing that that line P is perpendicular to both of them, we know now they are parallel. And that tells us that that other line intersecting those 2 lines creates an equal angle. So the angle that joins with A to be 180 degrees is equal to R, and both of those are equal to 30. So A plus that angle that's equal to R, which is 30, equal 180. So A equals 180 minus 30. That tells us angle A is 150. If angle A is 150, remember intersecting lines form vertical angles and opposite vertical angles are equal, so A and B are equal. So A plus B would be 300. Here we're dealing with algebraic inequality. Now, We want to know the ordered pairs in which r plus s are going to be greater than 1, but r minus s is less than negative 2. The simplest way to do this is simply work off the answer choices. That way we can easily eliminate some of them and find the one that's left as the correct answer. Well, we can kind of glance at it and see that 2 minus 1/4 is not going to be a negative value, so we can rule out E. And 1/2 plus 1/4 isn't even going to get us to 1, so it certainly can't be greater than 1. Then let's look at the others. 1 minus 2 is equal to negative 1. That's greater than negative 2 because it's less negative. 1 minus 3 is equal to negative 2, not less than. But with C, 1 minus 4 is equal to negative 3, and negative 3 is less than negative 2 because it's more negative. Now this geometry problem is concerned with finding the area of shaded regions. And to do that, you've got to subtract one geometric form from another. So we're going to subtract the area of those circles from the area of the rectangle. Now the sides of the rectangle, PQ and PS, are 8 and 12. So we multiply 8 times 12 and get 96. The area of that rectangle is 96. If the side QP is 8, that would be the diameter of that circle. So half of that would be 4. And the area of a full circle would be pi r squared. The area would be 4 squared times pi, or 16 pi. And to get the area of that shaded region, we subtract that 16 pi from the 96, which is the area of the rectangle, giving us an answer of 96 minus 16 pi. We'll call this one a numerical reasoning problem. This is number 8, so we're starting to encounter a little bit of difficulty here. The arithmetic isn't going to be too tough, but some of the terminology can be. In this case, they're trying to divert you with the term palindrome. Now, palindrome is a number that remains the same when the digits are reversed. They give you an example of 11,011 as an example. Now, they want to know which of the following terms in our answer choices is 2 times a palindrome. Okay, now remember, a palindrome repeats itself forwards and backwards. So 121 is a palindrome, 5775 is a palindrome, but 8779 is not. Again, this is number 8, so this isn't going to have a really difficult solution. And we look at it pretty simply. If we look at E, well, if we divide 44 by 2, we get 22. 22 is a palindrome, and 2 times 22 would be 44. So that gives us 44 is a number that is twice a palindrome. Now this is one of their goofy made-up functions. And what they're trying to do is distract you with goofy or strange symbols. Just remember, when you see a strange symbol, it means they're simply giving you a new rule to follow. And what you want to do is plug in your values and follow that rule rigorously. In this case, they give us A triangle B is equal to A divided by B minus B. And they want to know what the value of 8 triangle 2 is. Okay, 8 is in the A spot, 2 is in the B spot. So that tells us that's 8 divided by 2 minus 2, which would be 4 minus 2, or 2. Now keep in mind, made-up functions look distracting, but the math behind them is not very difficult. This can be almost free points. Now this question is asking you to find the area of a triangle, but they want you to do it a little bit abstractly because they're only giving you the coordinate points of the vertices of the triangle, saying they're at -2, -1, and 2 and 1, and 0 and 4 at those points. Okay, imagine or even sketch out your graph. You want the x and y axis, and then put that triangle in with its vertices at -2, -1, at 2 and -1, and at 0, 4. Looking at that, to go from 2 to -2 is a distance of 4. And to go from -1 to 4 is a distance of 5. So the height of the triangle will be 5. Now we highlighted that -1 there because a lot of people automatically see that 0 there with the 4 and put a height of 4 in, but it's a height of 5. So to get the area, 4 times 5 divided by 2 is 10. Now notice that they give you, if you had seen that height as 4, they've got 16 and 8 there as bait. One thing the SAT is good at is knowing where you're liable to make errors or misreads, and they'll have answer choices waiting for you. So finding an answer choice that matches yours is not always an effective check like it is on tests you take at school. This is another algebraic or numerical reasoning problem. Now we've got a, b, and c as integers greater than 1, and ab equals 12, and bc equals 27. Well, the only thing those two have in common is b. So we can evaluate this and see if we can find out what b is. If we look at the factors of 12 that are greater than 1, we find 2, 3, 4, 6, and 12. The factors of 27 that are greater than 1 are 3, 9, and 27. Well, the only factor that the two have in common is 3. That tells us then that b has to be 3. Well, if b is 3, then a has to be 4, and c has to be 9. So 9 is greater than 4, which is greater than 3. Substituting the letters back in, c is greater than a, which is greater than b. Here's another little abstraction. It deals here with a little bit with number properties. They say the tens digit of a two-digit number is 4, and the units digit, now the units are the ones, that digit is g. If the two-digit number is evenly divisible by g, which of the following cannot be the value of g? Well, look at what we've got. We've got 4g, and then you're going to substitute one of the numbers in the answer choices and find out which one is not evenly divisible by that number when that digit is in the ones or units place. Example, 42 divided by 2 is equal to 21. We put the 2 in the g spot. 44 divided by 4 is 11. 45 divided by 5 is 9. All of those go into it evenly. But now 46 divided by 6 comes out a fraction. So that won't work. Our answer's 6. Another little factor to keep in mind is that we're at question number 12. So we're in the last half of the test on a 20-question test. Once you start getting there and you're going to be plugging in values, we strongly suggest you start plugging in from the last. Because as in this case, it's uncanny how often the answer choice seems to be one of the last two. They want you to work as hard as you can to get to that answer choice, taking more time. Now this is a long word problem that involves percentages. Remember, when you see a long word problem, or any word problem for that matter, you want to get the numbers out of the words. In this case, 10% of the first 20 are red. 10% of 20 is 2. 30% of the next 30 were red. Well, 30% of 30 is 9. And 50% of the last 30 were red as well. So 50% of 30 is 15. That tells us we have 2 and 9 and 15, totaling 26 red beanbags. If there are 80 beanbags total, 26 divided by 80 is 0.325, or 32.5%. This is a geometry problem involving volume. Now to get volume of a rectangle is length times width times height. But this is a little bit trickier because it also involves ratio. It says the ratio of the length to width to height of a rectangular solid is 3 to 2 to 1. Now, what we have to do is realize there's going to be a factor that inflates each of those sides to get us to our volume of 6,000. We need to find out what that factor is to determine what the width of the rectangular solid is. So we simply take 3x, 2x, and x, making x that factor that inflates it, and multiply them together just like we would with length and width and height. That gives us 6x cubed. Then when we divide through by 6, we get 1,000. Well, 1,000 is 10 cubed. We're not through yet because we're looking for the width. Remember, the width is in that 2 spot. So 2 times 10, or 2 times that x factor, gives us 20 as the correct answer. This is a remainder problem. They give you a and say when it's divided by 6, the remainder is 4. What's the remainder of 8a divided by 6? The easiest way to do these problems is to pick a value that fits the statement, that makes it true. And I usually like to try to pick the smallest one that makes it true. In this case, 10 divided by 6. 6 goes one time into 10 and leaves a remainder, or a leftover number, of 4. Okay, saying that 10 is a, 8 times 10 would be 80. 80 divided by 6 goes 13 times with a remainder of 2. So 2 is our answer. Just pick a value that fits the statement and then work it through. This is a question really about the properties of fractions. The SAT loves to put a fraction in the denominator to see if you know that when a fraction is in the denominator, it flips. By that I mean you multiply the numerator by the reciprocal of the denominator. The reciprocal is the number that you would multiply by that fraction to get a result of 1. For instance, the reciprocal of 1/2 would be 2 over 1. The reciprocal of 2/3 would be 3/2. The reciprocal of 4/3 would be 3/4. So in this case, if we're dividing by 2/3, the reciprocal of that would be 3/2. So we take that reciprocal of 3/2 and we multiply it by 4/3, which gives us 12 divided by 6x, which equals 2x, which is the same as multiplying by 2. This is a change in average problem. The key to solving change in average problems is to realize they're vulnerable if you go out to the totals. We want the totals of the numbers. That's where we can work with these and get the right answers easily. In this case, the average of a, b, c, and d is 12. So a plus b plus c plus d over 4 equals 12. Multiplying both sides by 4, a plus b plus c plus d equals 48. Well, they tell us that the average of c and d is 4. So c plus d over 2 is 4. Therefore, c plus d totals 8. If we subtract c plus d from a plus b plus c plus d, we get 40. That tells us that a plus b equals 40. And we want their average. So it's 20. This is a slope problem. Remember, you find the slope by rise over run. By that I mean you divide the change in y by the change in x. In this case, the line passes through the origin and the point -3, -2. Well, let's look at the y coordinates. To go from -2 to 0 is a distance of 2. To go from -3 to 0 in the x coordinates, that's a distance of 3. So we divide the 2 by 3 and get 2/3. It tells us our slope is 2/3. And since it's 2/3, that tells us it's a positive 2/3 because we're going up from left to right. Now this is a problem concerning simultaneous equations. Remember, on the SAT, when you see simultaneous equations stacked up or side by side, focus on your target. Focus on what you want to get to. Then you're going to manipulate the equations to get there. We want a plus b plus c. That's our target. Now we looked at the equations we've got. 8b plus a equals 12 and 7b minus c equals 4. Now how in the heck are we going to get a, b, and c together in an equation? Well, if we look at it, the key here is 7b and 8b. If I subtract 7b from 8b, I'll get 1b. And I can also see that if I subtract that equation 7b minus c equals 4, that'll turn the c positive. So I've got 8b plus a equals 12, and from that I subtract 7b minus c equals 4. That means it's a negative 7b, a positive c, and a negative 4. That leaves me with a plus b plus c equals 8. I see this is question number 19. This is a difficult question, but if you focus on your target and realize that you can manipulate those equations, simultaneous equation problems aren't that tough. This problem kind of combines things. You've got to use your numerical reasoning, but they give it to you in an abstract form. So, as you've found out before, what we do is we try to make an abstraction real. Use numbers that make it so. And let's use easy numbers. We want an odd number of consecutive integers. 2 plus 3 plus 4 plus 5 plus 6. And they total 20. Now when you have an odd number of consecutive integers, the average is going to be the median. By that I mean it'll be the midpoint. So in this case our average is going to be 4. Now the greatest number is 6. So if we add 2 to the average, we will get the greatest of these 5 integers. This is another numerical reasoning problem, but it involves negative values. A and B are both negative fractions greater than -1, and A is greater than B. Then which of the following has the greatest values? Well, what we want to be sure and try to do here is to turn the most negative value we can positive. And remember, the key to this is going to be that if you multiply a negative by a negative, it turns it positive. And again, let's make this abstraction real. Give these numbers. Let's say that B is -1/2 and A is -1/4. And now let's walk through our values. A would be -1/4 plus -1/2, which would give us a -3/4. B would be -1/4 minus a -1/2. That gives us a -1/4 plus 1/2, which gives us a positive 1/4. Okay, that's our highest so far, so let's see if it'll stand. The next one, C, is -1/2 minus a -1/4. That gives us a -1/4. Then 2 times a -1/2 minus a -1/4 gives us a -3/4. The last one, 2 times a -1/4 minus a -1/2 gives us -1/2 plus 1/2, or 0. Now notice that this is question number 21, or it would be towards the last, and notice this is kind of a tedious, time-consuming problem. So you may want to leave this one for last. In other words, skip this one over and then come back to it, because it's obviously going to take a while to work it. We call these quicksand problems sometimes, because you get stuck in them. Now this is a probability problem, and a lot of students have a thing about these. They think they're difficult. Well, they aren't as long as you keep everything straight and keep in mind that all probability is you're dividing the desired outcome, what you're looking for, by the total possibilities. And always remember you have to add part of that desired outcome into the total possibilities. That's where people get thrown off. So in this case we've got a hat that has 54 green marbles, 24 blue, and the remainder yellow. And the probability of pulling a yellow one out is 1 out of 4. So we set up our equation. We've got the yellow, because that's what we're looking for, divided by the total. And the total would be the yellow marbles, the 54 green, and the 24 blue. Our outcome is 1/4. 54 and 24 add up to 78, so we've got y over y plus 78 equals 1/4. Now we simply cross multiply, which gives us 4y equals y plus 78. We subtract y from both sides. That gives us 3y equals 78. And when we divide through by 3, we find out that y, or the number of yellow marbles, is 26. Here we have a sequence. The first term of a sequence is -6, and every term after it is 5 more than the term immediately preceding it. What's the value of the 100th term? Well, the formula for a sequence is you want the value that you're looking for will equal the amount of increase, in this case 5, times the number of terms. Well, we want the 100th term, but we've got to discount that first one because we want the 100th term from it. So we can't count it twice. So that would be 100 minus 1, or 99. And 5 times 99 is 495. Now remember, the trick here is we started with a -6, so we went up 495 places from that -6, but we have to subtract that 6 out of there. So 495 minus 6 is 489. Well, this is another abstract problem. Noticing a trend here? Yeah, they do favor that. If Tim gets B bananas in addition to the Q bananas he had originally, he'll have N times as many as he had originally. In terms of B and N, how many bananas did Tim have originally? First thing, let's write this out. B plus Q, because he's getting Q more bananas, gives him N times what he had originally. And Q is what he had originally, so B plus Q equals N times Q. Now, the trick here is we want to solve for Q, so let's get the Q's together. We subtract Q from both sides, so that gives us B equals NQ minus Q. Now remember this little trick here of factoring. It opens up a lot of problems recently on the SAT. Group what you're looking for on one side and then factor it out. So if we factor Q out of NQ minus Q, we get Q times the quantity N minus 1. Dividing both sides by N minus 1, we get B over N minus 1 equals Q. You'll notice this is one abstraction where we kept the variables and didn't substitute numbers in. That's because from experience we found this particular problem is a little bit tricky when you substitute numbers in there. It's easy to make an error and get the wrong answer. And finally, we've got a geometry problem that has to do with triangle and area, but it's also tricky. This is a reasoning problem. One side of a triangle is a length of 4, the other side has a length of 5. Which of the following could be the area of the triangle? Could be is important here. If we have a right triangle and the sides 4 and 5 are at right angles to each other, think about it. That's the most area we can generate with those two sides. So 4 times 5 divided by 2. The most area we can possibly get out of those two sides is 10. That rules out 14. But we could have a smaller triangle. That could comes in here. We could have a triangle that had an area of 8, but we can't have one that has 14. So our answer here is D, 1 and 2 only.